Hello, everyone. Today we are focusing on isosceles triangles and equilateral triangles. So, a reminder: an isosceles triangle is a triangle with two congruent sides. Now, there's an isosceles triangle theorem that says if two sides of a triangle are congruent, then the angles opposite these sides are congruent. So, in our triangle here, if we know AB is congruent to AC, that means that angle B is congruent to angle C. Then the theorem also works backwards. So it says if two angles are congruent of a triangle, then the sides opposite the angles are congruent. So if I know B is congruent to C, that tells me that AB is congruent to AC. So now we got to identify the parts of an isosceles triangle. The angle between the congruent sides is called the vertex. So this angle up here is the vertex angle. The sides that are equal are called the legs. So this is a leg, and this is a leg. The unequal side, BC in this case, is called the base. And the two angles that are equal, which in this case is angle B and angle C, are the base angles. Actually, let me write the word angles. So let's apply the theorem up here. So if we know angle R, we know angle R is congruent to angle at V, which we need to be more specific. We name it UVR. And we know that because UR is congruent to VU. And so we know that by the isosceles triangle theorem. Then we also know that RT is equal to TS because angle R is congruent to angle S, and the isosceles triangle theorem tells us it works backwards as well. And then last but not least, VW is equal to WS because angle V equals angle S, and again, the isosceles triangle theorem. So examples, I want you to pause and I want you to try to find X and Y in both 1 and 2, and then come back. So to find X, I know that this triangle down here is isosceles, and these two sides are congruent, which means these two angles are congruent. So this angle is 55. Then we need to remember that in a triangle, all the angles add up to 180. So that means 55 plus 55 plus X equals 180. So that's 110 plus X equals 180. So that means X equals 70. So this angle is 70. Then we know that this side is also 70 because those are vertical angles. Then I'm going to do the same thing, but I know that these two base angles are both Y. So it's 70 plus Y equals 180. And that's 70 plus 2Y equals 180. So 2Y equals 180. Or 110, sorry, because I subtracted 70. So Y equals 55. Now this example is a little bit trickier because 110 is an exterior angle. So we need to remember that an exterior angle is equal to the two interior angles that are away from it added together. So in this case, it's going to be Y and 90 equals 110. So I subtract 90, and I find out Y equals 20. Now, I also know that 110 forms a straight line, so that means this side is 70. And then if I look at the large triangle, it's isosceles, so x equals 70. So now we have another example, number 3. Find the measure of angle 2 if the measure of angle 1 is 80, and we know that AX is parallel to BC, and we know that AB is congruent to AC. Well, first we're going to use the parallel. So knowing these two lines are parallel, I look and I see that this is a transversal that has angle 1 on it, which is 80. So if angle 1 is 80, angle ABC is also 80 because they're alternate interior angles, which means angle 2 also equals 80 because the isosceles triangle theorem. Next theorem, the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So that means if I draw an angle bisector, which means it makes angle BAD equal to angle CAD, that means it also is the perpendicular bisector of the base. So that means BD is equal to DC. This is only true in isosceles triangles. So here are 2 more examples that I want you to pause and try to figure out, and then come back and check. Okay, so welcome back. I know in this top one that angle L is 63, therefore angle N is 63, because LMN is an isosceles triangle, and therefore angle LMN plus 63 has to equal 180. So angle LMN is equal to 54. And then these 2 marks indicate that that's split in half. So y equals 54 divided by 2, which is 27. Then for angle x, that's x plus 27 plus 63 equals 180, because this makes a smaller triangle. So that's x plus 90 equals 180. So x equals 90. Now there is a faster way that I could have realized to begin with, that this is an angle bisector in an isosceles triangle. Therefore, this is a perpendicular because it's the perpendicular bisector. Number 5, first thing I do is realize that ABC is equilateral because all 3 sides are equal, which means all 3 angles are 60. Then I realize that this triangle, CDE, is isosceles, so these 2 base angles are the same. So 2x plus 50 equals 180. So 2x equals 130. X equals 65. These angles are 65. So now I'm going to see if I can answer the questions. So BCA is 60. DCE is 65. DEF, oh, that's an outside angle. Outside angle either equals 180 with the 65 or is equal to the 2 interior angles added together, 50 plus 65, so that's 115. BCD is this angle right here. Well, these 3 have to make a straight line. So 60 plus 65 plus, let's call it y, equals 180. So that's 125 plus y equals 180. So y equals 55. And then we have BAG. Well, BAG, again, is an exterior angle, so it's equal to 60 plus 60, which is 120. And GAH is vertical with 60, so it's 60. So that's the end of our video for tonight. If you have any questions, please let me know tomorrow in class.